Everybody, this is topic 1, Foundations of Geometry, specifically section 1.1, which is measuring segments and angles, and this is day 1 of 2. All right, we're going to start right here with undefined terms. Undefined terms are terms whose meanings are accepted without formal definition. All right, the undefined terms below are the basic building blocks of geometry. So we're going to start with a point is a location and has no size. When we are naming a point, we use a single capital letter. In this case, because the diagram has a P there, we would call this point P, but we can use any capital letter. Right. A line consists of infinitely many points on a straight path that extends in two opposite directions with no end and no thickness. We have two different ways we can name a line. The first would be with a single letter. So for example, we have this little script L here, so we call this line L. The second would be with any 2 points on the line. So we've got point A and point B, so we would call this line B. And in order to denote that this is a line, we need to include that little hat on top with the 2 arrows going in opposite directions. All right, and lastly of our undefined terms, we have a plane, which consists of infinitely many points and lines on a flat surface that extends without end and has no thickness. We also have 2 ways to name a plane. The first would be with a single capital letter. So we've got a little M here, so we could call this plane M. Or we could use 3 points in the plane specifically that do not lie on the same line. So we've got point X, Y, and Z. Those 3 points do not form a line, so we could call this plane XYZ. Alrighty, in geometry, new terms are defined using previously defined or known terms. So we have some more definitions here. Let's start with a segment is the part of a line that consists of 2 endpoints and all points between them. So when we are naming a segment, we're going to use both of the endpoints specifically. And just like how when we were naming a line, we gave it this little hat, a segment also needs a little hat, except the difference is that there's not going to be any arrows. And this just denotes that those are endpoints instead of just points on the line. A ray is the part of a line that consists of 1 endpoint and all of the points of the line on one side of that endpoint. So when we're naming a ray, we use the endpoint and any other point on the ray. In this case, M would be our endpoint and N is a point on that ray. So we would call this ray MN. And again, to denote that this is a ray, we need to give it this little hat with an arrow on one side and nothing on the other. Opposite rays are rays with the same endpoint that lie on the same line. When we name opposite rays, we name them just like we name a single ray. So in this case, let's use this guy, we have ray TS, and the opposite ray shares that endpoint T going in that opposite direction, right? So we have ray TU right there. All right. An angle is formed by 2 rays with the same endpoint. I want to stop there and look at this diagram. We have ray QR, and our common endpoint Q, because we have ray QP as well. So that would give us this angle in between those 2 rays. It says each ray is a side of the angle, and the common endpoint is the vertex of the angle. So just as we said, we have ray QR and ray QP, so that common endpoint would be Q, meaning Q would be called the vertex. Right. When we name an angle, we have 3 different options. The first is just by naming it based off the vertex, so we could have angle Q. The second would be using 3 points, and when we use these 3 points, the middle letter needs to be the vertex. So our example that's given is angle PQR. Right, we're following points P, Q, and R. However, we could also name this the opposite way. The only thing that needs to be true when we're using 3 points is that Q, or the vertex, needs to be in the middle. So we could also call this angle RQP. Right, if we're following our points, we go from R to Q to P, and it gives us that exact same angle. Then the third way to name an angle is just with a number. So we have angle 2 because we've got our 2 in there. That was a ton of definitions. Let's keep her moving. The length of a segment is a positive real number. The distance between any 2 points, in this case x and y, is the absolute value of the difference of their coordinates. This is the algebraic way to write what we just read. What is important here, and I'd like you to note, is this little bit right here, which says the notation xy without the little hat represents the length of ray xy. All right, I feel like this bit doesn't make a ton of sense just on its own, so let's go over an example and it should clear some things up. We've got our little diagram here and it asks us to find the length of AC. I see that A is at -3 and C is at 1. So we are going to take the absolute value of the difference of those two values. Okay, again, I'm talking about length, so I don't need a little hat on AC in this case. And AC is equal to the absolute value of A, which is at -3, minus C, which is at 1. All right, order doesn't really matter there. I could have done C minus A. I just picked this because I picked it. All right, I know that -3 minus 1 is -4, and the absolute value just makes a number positive because it is the distance from 0. So the absolute value of -4 is +4. Hit B for now and use that as a practice problem in class. So we've got a postulate, new definition, is a statement that is assumed to be true without proof. All right, our first postulate of geometry is the segment addition postulate. It says if points A, B, and C are on the same line, where B is in between A and C, then the length of AB plus the length of BC is equal to the length of AC. It's a little bit easier to see over here using this diagram. So we've got A, B, and C all in a line, and B is in between A and C. It then tells us that this length AB plus this length BC is equal to this total length AC. Okay, we're going to practice using that down here. So it tells us points F, G, and H are collinear. New vocabulary word, it says collinear points lie on the same line. So F, G, and H are all on the same line. It says if GH equals 16, what is FH? And I could see in the diagram over here that FG is equal to 3x minus 1, and GH is also equal to 2x plus 2. Okay, let's start with our segment addition postulate. Because FG and H are all on the same line because they're all collinear, and we can see in our picture that G is in between F and H, I can say then that the entire length of FH is equal to the length of FG plus the length of GH. Okay, I can replace that then with some more information. So we said here that FG is equal to 3x minus 1. So I'm going to replace FG with that 3x minus 1. We can see in our diagram that GH is equal to 2x plus 2. So I'm going to replace GH with 2x plus 2. All right. It also tells me in this beginning, or in the description, that GH is equal to 16. I'm going to set up a second equation for myself. So if I know that GH equals 16, and I also know that GH equals 2x plus 2, I'm going to combine those. 16 is equal to 2x plus 2. I'm going to use my algebra skills to solve that. So I'm going to subtract 2 for both sides. I'm going to get 14 equals 2x. I'm going to divide both sides by 2, and I'm going to find that 7 is equal to x. Because we know that, we can plug that into our equation. So whenever, our equation over here, I should say. So wherever there is an x, I'm now going to write a 7. So I know that FH is now equal to 3 times 7 minus 1 plus 2 times 7 plus 2. All right, we're using our algebra skills again. 3 times 7 is 21, minus 1 plus 2 times 7 is 14, plus 2. And then I know that FH is equal to 21 minus 1 is 20, plus 14 is 34, plus 2 is 36. Our last little bit says a midpoint of a segment is the point that bisects or divides the segment into two congruent segments. Congruent here means the same length. Okay, let's practice using that concept. It says that B is the midpoint of segment AC. AB is equal to 5x, BC is equal to 3x plus 4. And it asks us to find AB, BC, and AC. That's a lot of words, and I feel like a visual would help here. So we're going to start by drawing ourselves segment AC. Okay. It starts off by saying that B is the midpoint of this segment, which means that B is right in between A and C, right? That AB, that length, is the same as the length of BC. It also tells us that AB is 5x and that BC is 3x plus 4. All right, the important part here is that B is the midpoint, right? So because it's the midpoint, we already said AB is the same as BC. So I'm going to set 5x equal to 3x plus 4. Okay, I'm going to solve for x. That's going to help me out a little bit here. All right, 5x minus 3x gets me 2x. Divide both sides by 2. And I'm going to find that x is equal to 2. Okay. That helps me out, but it doesn't answer the actual question that was asked, right? Which was, I guess not a question, but to find AB, BC, and AC. Okay. Because we know x, though, we can use that to solve for those lengths. So we already said that AB is equal to 5x. We know that x is 2, so we know that AB has to be 10 units. Okay, that was a third of the question. I'm going to leave BC and AC finding those lengths for class.